I'm going to present about occupant voting systems for collecting continuous feedback, why we need to collect it, how we can collect it, and why to use occupant voting systems for collecting feedback. So just starting with an example, so I'm a senior specialist in Ramboll, and back in 2018, that was before I joined the team, we had a very beautifully designed construction we designed for a municipality in Denmark, which actually achieved a very high rating in one of the largest green certification schemes in Denmark. On paper, it really performed well. 1 year after the building was constructed, we had students going in and doing so-called post-occupancy evaluation, which is basically a user satisfaction survey about people's experience and perception of the indoor climate and the building. What we discovered was that 30% believed the noise level was not so good. The temperature was not very well according to the occupants, and there were some other expectations from the occupants that weren't fulfilled. And just to say, this is not a standalone case. This is something that we've encountered many times, especially previous research has established that what we design as engineers and architects is not necessarily always the same as how the occupants expect or need or require from the building. Another important consideration to have in mind is occupant feedback and energy efficiency of buildings. A study conducted by Park and colleagues, a part of the team at Carnegie Mellon University, they monitored 64 office buildings and actually discovered that the temperatures that were set in the building to create comfort actually led to higher rates of discomfort when you ask the occupants. So it's a good idea to ask the occupants, and at least ask as many occupants as possible, because it can actually help us to review some aspects of the building that can also improve energy efficiency. And that's why occupant feedback becomes interesting. Not only is it useful because buildings are centrally about creating a nice environment for the occupants, but we also need to make sure that the building isn't using more energy or resources than necessary. And again, occupant feedback can be useful for that. But the question is, how do we collect this information? So there are different types of ways of collecting this information. You could divide them into two spectrums. On the one end, you have the social idealist approach, which is based on qualitative methods. You have a person going in, doing observations, interviews with occupants and users, doing focus group interviews, or you ask the occupants to have a logbook of how they experienced the building. And then you have the more technical idealist solutions. As was presented in the last slides, you have sensors, you have how you can collect data on how people or occupants interact with the building. You can use questionnaires, and you can use these participatory voting systems. So the focus of this presentation is mostly focused on the technical idealist solutions and utilizing the concept of human as a sensor. So when we sense the environment, we get an impression, and this impression is expressed as an experience, and this experience we want to translate in something that a machine can understand, or that we can systemize in a way so we can compare to others' experience. So we want to make them into more quantitative type of values. And there are different types of methods that we can use for getting this type of occupant feedback. So we have typically in larger office buildings with established facility management systems, a so-called computer maintenance management system, also called the help desk, where an occupant can create a log or ticket about issues or relations in terms of the building. And this information can provide lots of sorts of information, but it's quite messy and requires a lot of data processing to get some useful information from these type of data. Then we have the questionnaires, which is a very common way of collecting this feedback. The issue with questionnaire is that they can be rather long, so we don't want to use questionnaires as a means of getting continuous feedback, especially not in a more real-life scenario or real-life buildings, because people will become tired of being asked to fill out questionnaires all the time. And therefore, the concept of participatory sensing systems, or especially in relation to buildings, occupant voting system becomes interesting as we try to utilize some simple technologies to get very simple feedback from occupants in a more continuous here and now way. So these OVS systems comes in different variety of shapes and interfaces. You can have them as a tablet placed in the office or your house. It can be in a form of more tangible devices, for example, with buttons, or you can utilize smartwatches, wearable devices, or smartphones for collecting this type of information. Yes, so there are some different considerations to have in mind, because it's a very special type of technology that needs to be carefully designed and carefully implemented in order to get high quality data, or to actually get data at all from the occupants. They heavily rely on people using these devices. So the first thing that is important to think about is the interface design and the user friendliness of this device. We had a meta-analysis where we collected the previous studies on these type of systems, and what we discovered was that those systems where more accessible type of technology was used, such as a wearable device versus a QR code put on a poster, which required you to take your phone, find a camera, take a picture in order to access the interface. So the wearable device actually provided higher rates of votes than the QR scanning type of interface. We also did a small scale study, a preliminary study, which actually suggested when you had a physical device in the room versus a smartphone app version of the same feedback panel, if you only had either of the solutions, people would use it in a similar frequency, but if both options were available, they would use the tangible device more because it was in the physical room. And those people we especially studied, they didn't use their phone as much, so that's why we saw that more accessible device received more votes. Then another concern to have is that this is a phenomenon that is typically seen when we introduce new piece of interactive technology in to people. So when you place these technologies or you introduce these type of technologies to people for the first time, the interest and curiosity is very high at the beginning. So people use it very frequently to begin with. You can actually see, this is from the study that I conducted with the occupant voting system we tested. If you see for the votes for fine, the green line, in the beginning, people voted frequently, but this voting pattern or frequency actually dropped over time. So this novelty effect is important to have in mind in order to sustain data collection over a long period of time. Then another concern is that for example, in an office environment, which we did most of the studies, it's important that they don't emit sound or light that is distracting and annoying. Otherwise, people would just become annoyed or cover it or do something with the device to turn it off. But on the other hand, it's important that it's not inconspicuous. Otherwise, people would think it's a dummy device. We encountered that actually with the feedback panel we had designed and put into the office space, as you've seen, because it wasn't wired. People thought that it wasn't working. And here, the mini orb, this is a study done by Richtenberg and colleagues who actually tried to use light, a very discrete type of light, to notify occupants about the presence of this device, which was a way to make people aware of this device and that it was connected and working. Then another important consideration is that if you want feedback from the occupant, you also need to provide them some sort of feedback. This can be in many ways. It can be in form of dashboards. In our study, the dashboard didn't provide much incentives for people to use the device. But the people provided feedback such as that, for example, they expected the device was actually used to control the indoor climate. So if the device was actually connected to control the HVAC, we might have had higher votes. Some people even expected to get reminders, and others expected that the building operator would actually use it to improve the condition of the building. In the study, the feedback wasn't provided to the building operators, but some of these expectations is important. So it's important to inform the occupants that we collect your feedback, and this feedback is used for this in order for them to see a usefulness with these type of devices. Okay, so just providing you with what this occupant feedback can be used for, and particularly for the study that we did, we wanted to basically collect the occupant feedback, and the intention wasn't to automate everything and to connect it to the HVAC system. The idea was to get more insights into occupants' preferences, and this information should be used in different ways to help the building operators optimize the building. So what we did was that we collected different types of measurements, and we got feedback on cold, warm, and fine, and draft and stuffy. And in our data processing and data validation, we discovered that only the thermal votes, too cold, too warm, and fine, had a statistical relationship with temperature and airflow. And for draft and stuffy, we didn't see any consistency in the data, so they were left out. So they didn't provide us with useful information. And this is just to show you how the sensors were placed and the office space and design. We had some temperature sensors located at the red dots, as you see, and the TIQ panel, the feedback panel, placed at the entrances. And what we could see is, so this is the summarized version of the results. It was a 6-month study. The top figures shows the indoor temperature and relative humidity. The bottom shows the daily percentage of votes. And this tells us how the temperature was in the office spaces and the voting pattern for during that period of time. And we can see that during November, December, the temperature was quite low, and also the number of complaints had increased at that time. Another useful way of illustrating the information was to do a model relating the temperature and airflow with the occupant votes to identify at which point, what point the temperature, what should the temperature be to have where people provide had a lowest complaint, and at what point could we achieve highest comfort in terms of the vote fine for the airflow. And this information provided us with some new set points, which we could use instead of the ones provided in the building. So this information helped us reduce the airflow and the temperature level, and based on a data model of the office space, we calculated that we could actually achieve 40% energy reduction and 10% increase in comfort by using this information based on the occupants' feedback. And this is just to say the high energy saving was because it's an all-air building, so reducing the airflow by 25% could really give us a high energy saving. Yeah, so just to recap, that occupant voting is important, and that getting here and now feedback can be achieved with OVS, and that the design implementation is important, and that the information is both useful for optimizing energy and occupant comfort.